In this lecture, we will learn about the observer design pattern and how to implement it in Python. Observer is a behavioral design pattern that lets you define a subscription mechanism to notify multiple objects about any events that happen to the object they are observing. We use the observer pattern when changing the state of an object may require changing other objects, and the actual set of objects is unknown beforehand, or when some objects in the program must observe others, but only for a limited time or in specific cases. Let's look at the pros and cons of using the observer design pattern. The advantages of this pattern are that you can establish relations between objects at runtime, and you can introduce new subscriber classes without having to change the publisher's code. The drawback of using observer is that subscribers are notified in random order. Let's learn how to implement the observer design pattern in Python. Up at the top of the code, we will type from ABC import ABC, abstract method. We will also type from random import randrange. Now let's create a class named subject that extends the ABC class. Inside of this class, we will use the abstract method annotation on an attach function that takes in two parameters, self and observer. For the function body, we will use the pass keyword. Then we will create a detach function and use the abstract method annotation. Our detach function will take in two parameters, self and observer, and we'll use the pass keyword in the function body. Then will come a function named notify with the abstract method annotation that takes in one parameter, self. Inside of the function body, we will use the pass keyword. Now we will create a concrete subject class that extends the subject class that we just created. Inside of this class, we will have a state variable initialized to a value of none and an observers variable initialized to an empty list. Inside of this class, we will create an attach function that takes in the self parameter and a parameter named observer. Inside of the attach function, we will print the message subject attached an observer to the console. Then we will append observer to the observers list. Next, we will implement the detach function that takes in two parameters, self and observer. Inside of this function, we will print the message subject attached an observer, and then we will remove the observer from the observers list. After that, we will implement the notify function that takes in the self parameter. Inside of this function, we will print subject notifying observers to the console. Then we will iterate over each observer in the observers list. On each observer, we will call the update function and pass in self. Then we will create a business logic function that takes in the self parameter. Inside of this function, we will print the new line character, followed by the message subject generating random number. Then we will set self.state equal to randrange with 0 passed in as the first argument and 100 passed in as the second argument. Next, we will print the message subject change state to, followed by the state cast to a string. Finally, we will call self.notify. Next, we will create a class named observer that extends the ABC class. This class will have one function named update, which uses the abstract method annotation and takes in two parameters, self and subject. Inside of this function, we will use the pass keyword. Next, we will create a class named concreteObserver1 that extends the observer class. Inside of this class, we will define an update function that takes in two parameters, self and subject. Inside of the update function, we will check if subject.state is less than 50. If that is the case, we will print concreteObserver1 reacted to the event to the console. Then we will create a class named concreteObserver2 that extends the observer class. Inside of this class, we will define an update function that takes in two parameters, self and subject. Inside of the update function, we will check if subject.state is greater than or equal to 50. If that is the case, we will print concreteObserver2 reacted to the event to the console. Time to test our code. First, we will create a variable named subject, set equal to a concrete subject object. Then we will create a variable named observer1, set to a concrete observer1 object. After that, we will call subject.attach and pass in observer1. Then we will create a variable named observer2, set to a concrete observer2 object. We will call subject.attach and pass in observer2. Then we will call subject.businessLogic 3 times. After that, we will call subject.detach and pass in observer1. Finally, we will call subject.businessLogic again. When we run the code, you will notice a bunch of output was printed to the console. Since this code uses random number generation, your print statements won't look exactly the same as mine. First, notice that our two observers were attached to the subject. The subject generates the first random number, and then changes its state to that number. Then the subject notifies the observers about its state change. If the number is less than 50, observer 1 will react to the event. If the number is greater than 50, observer 2 will react to the event. The same thing happens 2 more times as the subject generates the random number, then changes its state, notifies its observers, and then the proper observer reacts to the event. Then observer 1 is detached before the business logic is executed again, so this time there is a 50-50 chance that the event will be reacted to. If the random number is less than 50, observer 1 will no longer react since it was detached from the subject. In the next lecture, we will learn about the state design pattern and how to implement it in Python.